So this is the second part of the notes on drawing atomic models, and it's a little more challenging, as I said, than the first part, but it's also more true to what we see in nature, and it's going to sort of answer some of those questions that you may have had earlier, like how can an orbital have 18 electrons but only 8 valence electrons? If this starts to seem too big and way too confusing, you really don't need it at this level, so you can wait until you hit general chemistry. But if you're looking for either a little more challenge, or if you do almost like the 3+ level, a lot more challenge, I think you're going to really start to understand a little bit more about how the atom is structured. So this was sort of where we left off with the last notes, and we had oxygen, and it had its 2 energy levels. The inner energy level with 2 electrons, and then the outer energy level with 6 electrons. And what we find is, though, that the electrons don't actually orbit in these fixed circles the way they look here. There's actually sublevels in different energy levels. And so we call those sublevels orbitals. And we give them letters, S, P, D, and F. And don't worry about where those letters came from. Quite frankly, I'm not even really sure where those letters come from. I think I read it at one point in time, but it clearly didn't stick. But they go in that order, S, P, D, and F. And so, for example, oxygen here has 6 electrons in its outermost shell. It turns out, though, that those electrons are both s orbitals and p orbitals. And just like electrons in the inner shell have less energy than electrons in the outer shell, s electrons have a little less energy than p electrons. So of those 6 electrons, 6 valence electrons, some of them are s, and they have a little less energy than those that are p. And so we're going to look at how that kind of breaks down in the atom. So here's a diagram, and I'm going to try to explain the different parts of the diagram. So down here would be the nucleus. And just like before, we're going to fill orbitals from the bottom going upward, because as you go upward, you increase in energy. So let's fill the lowest energy electrons first. Each of these colored boxes can hold 2 electrons. So when we talk about the first energy level holding 2 electrons, you'll notice there's just one box down here, right here, and that could hold 2 electrons. Then we say the second energy level can hold 8, and that would be all of these number 2 electrons. So these numbers correspond to what we were calling the energy levels before. So here would be like energy level or shell 1, here's shell 2, here's 3, here's 4, and you'll notice here's that weird 3 where I said before that level 3 can hold 8 electrons, sort of. Here's the 8 electrons we were talking about. But what's interesting is after the 4 s electrons fill, those 2 that we said, we said 2, 8, 8, 2, the next level actually is a 3 level. And so that can hold 10 electrons. So you can see like the 1s level could hold 2 electrons, and then the 2s level holds 2, and then the 2p, which is a little more energy, holds 2, 4, 6. The 3d would hold 2, 4, 6, 8, 10. Now you'll notice there are no f electrons on this diagram. We will never get to f electrons in this class, but one of the ways you can remember it is that as you go s, p, d, f, you count by odd numbers. So s orbitals, there's 1 s orbital. P orbitals, there are 1, 3 p orbitals. D orbitals, 1, 3, 5 d orbitals. So how many f orbitals do you think there are? You should say 7, meaning 14 electrons, because each orbital can hold 2 electrons. And if you look at your periodic table, you may now be able to see there are some kind of chunks of the periodic table where it's almost like a row of 2, and some chunks where it's almost like a row of 6, and some where it's like a row of 10, and some where it's like a row of 14. And you can even find periodic tables that will break the table down into S blocks, P blocks, D blocks, and F blocks. By the way, I don't think I said, don't worry about the shape of these orbitals. S orbitals look kind of like a sphere, and some people remember S and sphere. P orbitals, I once had somebody say, I always thought they looked like dumbbells or figure eights, but somebody said, well, you can remember P because it looks like a peanut, like a full peanut in its shell. But D orbitals, some of them are a little blobby, some of them look almost like donut rings. You can Google image orbitals if you're interested and kind of see what these shapes look like, but I wouldn't stress about it either. Now, one of the things that's interesting to note, and that's this last bullet point here, is because of the way electrons are configured, the 4s level actually fills up before the 3d level. The 4s level actually is at a lower energy than the 3d. Which is why, if we're sticking with the first 20 elements, we don't even need to worry about this part. And the 4 electrons would still be the valence electrons because they're still the outermost electrons. And so those are still the electrons that are going to bond with other atoms. But that's why this is a little more true to what we see, but a little more confusing. Because if you had an element that, say, went up to number 21. So this would be 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. Electron 21 goes here in the 3D level, not here in the 4p level. And so that's why this gets a little more confusing. And I'm going to show you a way that you can remember that. Now, for those of you who are kind of level 2 pluses, as we talked about, or even say 3 minuses. You can do 3, but you struggle a little. You only need to understand up through 4s. I'll never give you an element over number 20, so you don't have to worry about the 3ds or even the 4ps. Those of you who feel like solid 3s or even 3 pluses, you really like that extra challenge and you think you can handle it, you guys are going to get into the 3ds and even the 4ps and maybe even the 4Ds and the 5S's. I'm still, nobody is going to get any F elements though. Alright, so let's take an example. Okay, so let's say you're writing an electron configuration for sodium. Sodium has 11 electrons when it's neutral. So you're going to fill in electrons this way. So my first 2 go here. And then my second 2 go here at the 2s level. Now, my next electron is at the 2p level, so I have 4, I need 7 more, so I'm going to put 1 here, so that's number 5, 6, and 7. You'll notice I'm putting the electrons in separate p orbitals. I don't double them up until I have to. That's because electrons are negative, and so they like to repel each other. So we're always going to fill equivalent orbitals, so they're all 2p orbitals. We're going to fill them singly, one by one, before we start to double them up. And so then we're going to say, let's see, I'm at 2, 4, 5, 6, 7, 8, 9, 10, and then I need another one, 11. So this would be what we would call the electron configuration for sodium. And then the way we write it is down here. So let's see, let's get our pen here. And we can highlight. This is the way we're going to write that right here. So we write it as it sounds. 1, let's get rid of that now. Let's go back to our arrow. So 1s2 is here. So here's the 1s, and then the 2 stands for how many electrons are in there, and that's a superscript 2. And then 2s1, 2, 2s2. And then the 2p6, 246, that's right here, and then the 3s1, 3s1. And that's pretty easy to write. As you get into some of the bigger elements, say with 30 or even 40 electrons, you can imagine this chain here is going to get really long. So one of the things we can do is, if we go back here, is that this portion here, the 1s2, 2s2, 2p6, is equivalent to neon's electron configuration. And so we can write this as neon in brackets 3s1, because the 3s1 is what's different from neon. We can always go back to the previous noble gas. Now, if we had the next element, which I believe is magnesium, we wouldn't say sodium 3s2 or sodium 3s1 or anything like that. We would still go back to neon and say neon 3s2. So we always go back to the previous noble gas if you want kind of an abbreviation for that. Alright, so one of the things that may be helpful is this diagram. So this, the increasing energy is kind of flipped. So this down here is the higher energy. And the way you can write this is this shows you in what order you fill your orbitals. So if you look going across, you'll notice that it just lists the orbitals. So there's the 1s, and then here's 2s and 2p, and then 3s, 3p, 3d, 4s, 4p, 4d, 4f. So the actual energy levels are written horizontally. But then, if you put in diagonal arrows, these arrows show you the order in which you fill orbitals. So you have 1s, and then you go 2s, and then 2p and 3s. So far it follows the pattern we would expect. Then 3p, 4s. Then you'll notice now we say, oh, now we go back to 3d, then 4p and 5s. Then 4d, 5p and 6s. Then 4f, 5d, 6p, 7s, and so forth. As I said, we will never in this class get into the F electrons, but if you look at your periodic table, you can probably figure out which electrons would use those F electrons, remembering that each one has 2 electrons, and at the F level there are 7 orbitals. So that should kind of help you with, say, the 2 plus to 3 plus levels. A way you can figure out where you are if you, as I said, think you can do this just up to the 4s electrons here, so just these first 4 arrows. That would be kind of the middle level. I would call that a 2 plus or level 3, anywhere in there. And then if you think that you're ready to start conquering the d orbitals, that would be 3 plus for this assignment.